This explainer is designed to examine how artificial intelligence systems actually behave in a production environment. This is a very different context from a typical demonstration.
This statement is our core principle. The entire focus of this analysis is on systemic outcomes, not on the specifics of implementation.
We'll proceed in 5 sections. First, we'll look at the current focus of the AI conversation. Then, we'll define the operational gap this creates. After that, we'll propose a systems-first solution, outline its 2 main tenets, and then conclude with the mission behind this analysis.
So, let's begin by defining the current landscape of most content related to artificial intelligence.
The conversation today is almost entirely dominated by tools and platforms. What's left tends to focus on isolated demonstrations. The critical piece that's consistently overlooked is the systemic context that's required for any real production use.
Well, this oversight creates a significant gap between what we see in a demonstration environment and what happens in operational reality.
This perspective is drawn directly from mission-critical industries. Think about pharmaceutical manufacturing or global supply chains. In those contexts, unexpected system behavior isn't some theoretical problem. Operations simply halt. So, the distinction between a demo and an operational system is quite stark. The impact of a failure shifts from being theoretical to having very concrete consequences. The system's boundaries go from being isolated to being deeply integrated. And because of that, the core priority has to shift from just proving a capability to actually ensuring predictability.
To address this gap, we have to pivot away from a tool-centric view and instead adopt a systems-first perspective.
This really forms the argument for a systems-first hierarchy. You must define your constraints before you design an architecture. And you must establish correctness before you think about scale.
This hierarchy essentially inverts the common approach. Correctness is the foundation. From there, we define the system's operational constraints. Only then do we design the architecture. The choice of tools becomes the final consideration, not the starting point.
Now, this systems-first perspective is informed by 2 main principles, or tenets.
Before we go further, we need to define a key term, an unbounded probabilistic system. This is any component that lacks clearly defined operational limits, predictable fallbacks, or established performance guarantees.
And this brings us to the first tenet. The problem isn't that AI components are probabilistic by nature. The problem is that they are often deployed without the necessary engineering controls or systemic bounds.
So what does bounding a system mean in practice? It means applying concrete engineering methods, things like implementing defined interfaces, engineering deterministic fallbacks for when a component is uncertain, establishing clear human oversight, enforcing strict performance and resource constraints, and ensuring the complete traceability of the system's behavior.
The second tenet reframes the role of regulation. It shouldn't be seen as an obstacle, but as a catalyst. Regulation really acts as a forcing function for the kind of clarity, traceability, and defensible design that any critical operational system ought to have.
To close, I want to add a brief note on the mission and method that we use for this explainer. This analysis is intentionally vendor-agnostic, and it's pattern-based. It's abstracted away from any specific implementation, and it's informed by decades of actual operational practice.
The mission here is simple: to help move AI out of the hype cycle and into production. This is especially true for environments where reliability and accountability are not optional.
The very method used to create this explainer is itself a demonstration of the philosophy. The ideas were authored and structured entirely by human judgment. The expression and narration were then performed using AI assisted synthesis. This reflects a responsible use of these systems as powerful assistive components, not as autonomous authorities.
Beyond hype, into production.